Hello everyone, welcome to another topic electrical calculations. So today we will see about very basic electrical calculations that we can use in our day-to-day activities. So let's speak of what is electricity. Electricity is nothing but it is flow of electrical charge in simpler terms, not going by definition, but basically we can simply define it as a flow of electrical charge. So how does it flow? Okay, see, we know that water will flow from higher point to the lower point. Okay, so it flows towards the lower point. Okay, so similarly electricity even flows in the same way. So the difference between the higher potential to lower potential, okay, it always flows from higher potential to lower potential. Considering ground as zero potential, electricity will always tries to move to zero potential, that is ground. That is the reason we will get shock in most of the times. Okay, we get shock in two conditions: either the electricity will flow through our body to the ground, or it will flow through our body closing the circuit to another point of contact. Okay, so in these two conditions we will have shocks. So here we term this thing as voltage. So basically what is voltage? The difference, the potential difference between any two points. Okay, that means high potential to low potential. This is termed as voltage. Normally voltage is represented as V, or the unit is volts. Okay, similarly amps. What is amps? Normally amps is current. Okay, that is nothing but the flow of electrons. Flow of electrons is called current, represented by amps, denoted by A, okay, or amps. Or in representation can be represented as I as well. Okay, right. Now we can simply use Ohm's law, okay, which states that voltage equal to current times resistance. What is this resistance? Resistance, what it does is it resists the flow of current. So higher the resistance, the lower should be the current. Okay, if lower the resistance, the easier it becomes, it becomes easier for the current to flow. Similarly here what happens is it resists the current, so the current flow will be bit low. So how can we calculate this? See, if for example in our daily household activities, we use 220 volts. If in India 220 volts to 230 volts. Okay, we have this current or electricity or power running at about 50 hertz. Okay, if it is abroad, it is different. We have 110 volt system with 60 hertz, okay, frequency. But here in India, we have this 220 volts to 220 to 230 volt system with 50 hertz. Okay, so basically we take this value. So here, see, for suppose if there is the system which runs on 230 volts on 50 hertz, and if the resistance which is denoted by ohms, okay, if we take there is a resistance of 10 ohms, and we have to find out the current flowing through the circuit. Normally it, the current doesn't flow until and unless there is a closed loop. Okay, for example this is the source, okay, and this is your resistance which is 10 ohm. Okay, and here across this we are having 230 volts. So what is the current which will flow here? Okay. So simply we have voltage We have resistance, we just need to substitute in this one. Say 230 volts equal to current into 10 ohms. I equal to 230 divided by 10. That means how much we are having? 23 amps. In a similar case, so for example, instead of 10 amps, okay, instead of 10 amps, if I am reducing the resistance to 1 ohm, let's see what will happen. Okay, so 230 volts equal to current into 1 ohm. I equal to 230 divided by 1, it is 230 amps. So you see, I did not do anything. Here we can clearly observe that if the resistance is less, the current flow is more. Okay, so lower the resistance, higher the current flow. Higher the resistance, lower the current flow. Okay, so how and what will be the effects of high voltage, low voltage, or high current or low current on our body? We are discussing this in prospect with safety, in respect of safety. So we will only discuss in that way. Okay, so here, if the resistance is less, then the current flow will be more. So when the resistance will be less, what are the conditions? Like see, if you are taking a human body, if a human body in dry condition, okay, the resistance will be high. If the same body in wet condition, the resistance will be low. Because water is conductor, it can just pass through our skin very easily. So in that cases, we are tend to get more shock, okay, than the dry condition, and it depends upon the path on which the electricity travels through the body. That also determines the severity of electrical shock on human body. So that is a topic for another time. But for now, we will concentrate on this basic calculation aspects. So we have seen how to calculate current with if voltage and resistance is given. Similarly, we can calculate another terms like if current and resistance is given, we can calculate the voltage. If voltage and current is given, we can calculate resistance. So next, we will see what is power. Power is nothing but voltage into current. Voltage into current. Okay. So the unit of power is watts. We can even name it as wattage or watts, that is V into I. Or we can rewrite this equation. We know V equal to IR. So if you substitute that I into R into I, that becomes I square R. So if you only have current and resistance, you can even then you can find out watts by using this formula. Okay. If only you know voltage and you don't know current, then current equal to V by R. If we use this, then watts equal to V into I, that is V into V by R, that is equal to V square by R. Okay, so if we know voltage and resistance, even through that we can find out what is watts. So basically, in wattage, if we say we are having 1000 watts of power, then we use this term which is 1 kilowatt. Okay, so for every 1000, this k becomes m. Okay, 1000 kilowatt equal to 1 megawatt. Okay, so similarly we can use this formulas, okay, for power, for calculating the power and wattage. For example, we will see if voltage is 230 volts and power current is 4 amps. Okay, so then what is the total wattage? That is 230 into 4. Approximately you can just put it as 1 kV. Okay, 1 kilowatt. Or it is like 230 if you want to do it exactly. Okay, so 230 into 4 is somewhere at about 920 watts. Okay, and if you take transformer, you will see the term as kVA. See here, VA is nothing but again watts, right? So for transformer ratings, we'll be using kVA, and for general power consumption things, we'll be using kilowatts. But it's both are same. And here we have some more factors to take into consideration when we are when we are talking about KVS and all. So that is why it varies a bit, but both are nearly same. Okay, fine. Now let's say if there is two resistances in series and parallel. So what is the condition if there are two resistances in series, R1 and R2? Let's suppose, see, if there is R1 and R2, okay, these resistance are in series and I am having a source here. So what will be the total resistance? The total resistance is R total equal to R1 plus R2. Now if I have voltage here and I need to find out current. So what will be the formula? Voltage equal to current into total resistance. So that is R1 plus R2. So let's say we are having 2 ohms here and 3 ohms here and we have 230 volts. What will be the current flow? So I equal to V divided by R1 plus R2. V is 230 volts and divided by R1 plus R2, 2 plus 3, that is equal to 5. So 230 divided by 5. How much we are getting? That will be the current which this circuit will take. Okay, that is almost equal to 46 amps. Now, in the similar example, what happens if the resistance are kept in parallel? Say, let's just redraw the same thing, R1, and we have R2, and we have voltage source, right? So this is a setup of parallel, okay? V equal to 230 volts, R1 is 2 ohms, and R3 is 3 ohms. So in order to find out resistance for parallel circuits, so the total resistance will be 1 by RT equal to 1 by R1 plus 1 by R2. So or else you can rewrite this equation as RT, okay, 1 by RT equal to R1 plus R2 divided by R1 into R. Yeah. So what is the R total? R total equal to R1 into R2 divided by R1 plus R. Okay. So here R1 into R2, 2 into 3 divided by 2 plus 3. 2 3 is 6, 2 plus 3 is 5. So if we'll calculate this, what is the resistance we are getting? 6 divided by 5, it is 1.2 ohms, right? So you see, in series, the resistances are getting added up. Okay, so we can see the less current passing through the circuit. But in parallel, okay, we are reducing the resistance. So if we calculate power for this, let's see what will happen. Now we have total of R. So I equal to V by R. V we know as 230 volts divided by 1.2 ohms. So here what is happening? 230 divided by 1.2 is 191.6 amps. Okay, the current will increase. So that is what we have discussed earlier. So these are the very basic mathematics that you can easily identify of how to calculate voltage, power, and if the resistances are in series and parallel. So basically, these basic calculations will be sufficient even if people are practicing for ASP and CSP. So we will just end this topic here. Thank you. Thank you very much.